Hi, my name is Prithviraj Keswani. I'm in my third year of computer engineering at York University, Lassonde School of Engineering. Today I'm going to talk to you about my final project for EECS 2032, Winter 2021. This project overall helped me learn more about embedded systems and understand how sensors and actuators work. And also, this project will be really useful for me that in the future when I do have to work with some sensors such as what I've used for my project, I will already have the knowledge and understanding of how they work and what I have to do. Thank you and enjoy. So my project is called an air quality control sensor module, and the main object of my project is to measure air quality in an indoor setting and to understand how air quality around us works. Uh, this project is entirely new as nothing like this has been done before that measures altitude, carbon dioxide, air quality, and as well as temperature and humidity values. All the program and the hardware was developed entirely by me, with using some implementation techniques for just the hardware and the troubleshooting from the Arduino based libraries. This is entirely this entire industrial and commercially available technology and devices. The closest thing that are available right now are just what is available off our cell phones or off larger devices. Here is the overall image of the project, overall view of the project. This is what I designed myself. And then moving on, I'm going to move on next to the schematic of my hardware design. As you can see, here is the hardware design. So I have my temperature sensor is my blue one on the right where the mouse is. Then moving on is my BME280, my MQ135, MQ9 gas sensor, interfacing it all the way. So interfacing it to ground and the positive, and then going in as well here. And then that's pretty much it. And then the LCD display as well here. Now moving on to the schematic of the flowchart of my program. So here is my basic flowchart. Starts with just initialization, like just calling all the variables, and then moving on to the BMP sensor status. It's a status check, yes or no. Shows an error. If it's a no, it will show an error message on the LCD. Moving on, it enters the void loop of the Arduino code of the sketch. Initializes variables for the sensors there using the float and the int values. And then he calculates the values using for the data sheet MQ9 and MQ135. And then the serial print commands and runs check sensors if are working again or not. If no, if it doesn't work, it says an error message on the LCD. If everything works, everything should output on the LCD as well. As it can be seen here, all of the hardware was designed and developed especially by me, by no one else. Everything here was done original. All the hardware design here was original, just using a few implementations from the troubleshooting and other sources as well. That will be mentioned later. As you can see here is the program now. We start with including our libraries, and then for the LCD command, and then declaring our variables. Defining the pins for every single sensor, including the BMP, MQ135, MQ9, DHT. So the MQ9 and the MQ135 work on the analog pins. The DHT works on the two communication pins, and the BMP just works on the standard pin as well. Moving on, we have the void setup here where we just start with the serial begin. That's for the starting the LCD port, LCD backlight, and that just turns on the LCD, and DHT begin turns on the temperature sensor. And then for the BMP was set up in a different way that if in the setup, we added an if statement where if it doesn't work, then it will give an error message. And then going down, we have the default settings from the data sheet as well. And everything is commented. Moving down in the void loop, we have the sensor variables as float and then the MQ135 value as an int variable. And we calculate the average MQ9 value using an MQ9 and an analog read value. That's how it's supposed to be calculated and dividing it by 100. And we do something similar for the MQ135 as well using the sensor voltage as well. Moving on, we have the serial prints. This is a backup, everything printing in the serial monitor, and I can verify the code right now and see if it runs. And here is the serial monitor as well printing everything. Going down, we just have if statement set up. This if statement set up that if the sensor works, print serial print, and then moving down, we have the simple LCD prints at LCD.print air qual, ppm, CO2, and so on. And then we have a 3-second delay at the end, and that's pretty much it. Technical problems faced by me were mainly based on my sensor not working at all.
at first due to not being configured right, and then also the sensor inputting too much voltage, so it started smoking out. That was one issue, and the only way to fix it was for me to repair it or and pick up a new sensor. A few other technical issues I had was with the code. At first, when the sensors were not calibrated correctly, having sort of a different values than what it was supposed to be above. It was also mentioned in the report that how the values were sort of like 1 or 2 degrees above and below, and the same with the percent. And the gas sensors were working really well as they were really simple to implement, just using analog read functions that we already learned in class. To commercialize this project, we could eventually set up a custom PCB board and also set up. This does have a lot of market, especially for people who are climbing mountains or like people camping as well. It's something. It's really you could use an Arduino Nano and or Arduino Mini or even a mini Pi board to set it up. And my project was 100% successful. Uh, Mainly, something I could have done differently was just to manage my time a little bit better, I guess. And then working during COVID-19 and all the problems it caused was at the same time with the lockdowns and waiting for shipping, I guess. Just would have been that would have been great to keep in mind as well. I guess even if we have the full dedication and time, we can always get our projects done. I guess that's one thing I learned as well. And that's pretty much it.